Welcome to the project presentation for DAMG 6210 for 2024 online. Team 1, are you ready to go?
Yes, we're
Yeah,
ready.
Okay, it's all yours.
good afternoon, everyone. Today we'll present the online restaurant management system database. It's designed to streamline restaurant operations. Our team, 乐尊、伯特网、传卫雄、宇城冠, and Yu Bowu, we work together to build this system that tackles key operational challenges in modern restaurants. And the primary purpose of this database is to manage essential restaurant operations, including online ordering, delivery, reservations, and custom data. It serves as a comprehensive tool for administrative staff to streamline daily operations, such as menu management, order processing, inventory tracking, and collecting customer feedback. Our database solves several crucial business challenges. It helps maintain detailed record of the menu items, ingredients, customers' orders, and the reservations. Additionally, it ensures efficient handling of both in-store and online orders. The system enhances customer service by tracking feedback and staff schedules. Furthermore, real-time update for table reservations optimize seating arrangements and improve overall operational efficiency.
Our database design consists of 12 tables, which collectively form the foundation of the restaurant management system. This table handles customer management, menu maintenance, and order processing. Let me focus on two key tables, order and customers, to illustrate the system's design. The order table records all customer orders, including dine-in and delivery. It links to the customer table to track the customer placing the order. This table serves as the core of the system, integrating data from various modules to support operation and analytics. The customer table stores customer information like names, contact details. It is linked to the order table, enabling the system to log each customer's order history. This table provides the foundation for customer management and personalized service. Through this example, we can see how the tables work together to manage the restaurant operations. Moving on to create table and insert data. These two steps are critical for the database to function correctly. Create the table establish the structure and the relationship within the database. For example, primary key ensure that each record is unique, while foreign keys maintain consistency across related tables. These rules guarantee that the data is reliable and well organized. Insert data provides the initial data necessary for testing and real-world operations. It ensures the system to handle various tasks such as order processing, customer management, and inventory tracking. And welcome to next.
So in our database, we also implemented table-level check constraints. The first one is in customer review table. First, we created a function-based check constraint that ensures all the rating values on the restaurant's orders can only be 1 through 5, 5 different integers. This is done by this function that counts any ratings that fall outside this range, and then deny that range until it's valid to be within the range. Next, please. Secondly, we have a unique constraint on the same table's order ID column, which prevents multiple reviews for the same order. This is to ensure that the order number and the review and the customer's numbers are 1 to 1 to 1 always. Together, these constraints will help maintain the data integrity and enforce all the business rules. Also, to protect privacy and sensitive information like customers' phone and email address, we implemented encryption using a multi-layered approach. We have a master key, a certificate, and then using a symmetric key to encrypt that certificate. The initial data encrypted by having this added encrypted column to the customers table. To do that, we first open the symmetric key to decrypt the certificate, and then we encrypt the phone and email data into binary values. And after everything is done, we close the key. After encryption is set in place, we have to have this new procedure that takes raw plain text input of new customers' phone and email information and encrypt them using the same key before actually adding them to the customer table. And finally, after everything is done, we have this little safety procedure that makes sure all the left unencrypted keys somehow are safe and stored in our database. Thank you.
Okay, the next, I'll introduce the data views in our management system. The first view is order details. This provides a summary of each order. It shows customer names, table numbers, staff, couriers, and make it easier to monitor both dine-in and delivery operations. And the second view is the customer reviews. This displays customer names and their comments, ratings, and review date. It's very important for evaluating customer feedback. The third view is the top selling items. This identifies the most popular menu items by calculating the total sales and the revenue for each dish. This information supports decisions about the menu optimizations and item recommendations. And the next one is the menu inventory views. This helps manage stock efficiently. It links menu items with their ingredients and displays details like quantities and stock status. This ensures that kitchen can track the inventory. The last one is the customer address review views. This organizes customer contact details such as address and zip code. It's particularly important for managing deliveries and marketing.
We use Power BI to help with the visual report. This first fig shows the percentage of orders at different rating scores with a fan chart. It helps to analyze the overall quality of customer feedback. From the data presented in the chart for the past few days, we can see that the highest rating occupies a larger portion. This reflects that most customers are satisfied with the services and product of the restaurant. And for the time being, there are no low ratings like 1 or 2, indicating that no customers are currently dissatisfied. If there are subsequent orders with low ratings, it is necessary to focus on the low-rated orders to identify potential problems and make improvements. This chart helps us identify the strengths or room for the improvement. Then further, we can optimize products or services to improve customer satisfaction. Next. This graph shows the trend of daily order revenues, with revenue sources divided into delivery orders and dine-in orders, presented in the form of a folded line respectively. This makes it easier to visually compare the changes in revenues between the two order types. We can see that dine-in revenue contributes more to the overall business. We should analyze the reasons for this and maintain continuous growth. Delivery order revenue is lower overall and needs to be further analyzed to enhance its growth potential. This graph can provide us a strong support for operational decisions. Above all, it's all about our project. Thank you for your attention. Does anyone have any questions?
Yes. How are you tracking the payments for these orders? Is there a payment entity?
You want to check the payment for the orders?
Yeah.
The payment. We actually we just have the total price for each order. That's the payment. You can see from the ERD. Here we have each order. We have a total price here, which is
Yeah, like more information about the mode of payment, like cash, credit card, etc.
Yeah, we should consider that. Like we should consider improve the database by adding the payment type. That's a good advice. Thank you. Any more questions?
Oh, my apologies. I was muted. I was talking to myself. Okay. Yeah. Great work and presentation from Team One. Your data analysis was great. And thank you for the question. Thank you. Thank you all. Let's welcome Team Two.
Yes.
Yeah, I will share my screen.
No, Advait, it's still not visible. Yeah.
Just
Yeah.
is it visible now?
Yeah, you
Yes.
are on.
Is everyone ready?
Yeah, can we start, Professor?
Yeah, go ahead, please.
Okay. Good morning, everyone. Today, we Team 2 as a part of DAMG 6210. We are presenting to you our final project, Virtual Idol Management Database. I am Krisha Lakhani, joined by Reena Su, Advait Relekar, Ritika Bhanushali, and Prayag Adhikari. Today, we've developed a database system that aims to simplify and enhance the management of virtual idol activities. We'll move on to what our project is all about. Virtual YouTubers or VTubers, what are they? They are rapidly growing phenomenon in online content creation. These digital personas often they are inspired by anime and they use motion capture or virtual tools to interact with the audiences without revealing their real identity. Our project's purpose is to design a comprehensive database that tracks VTubers' profiles, manages their live streams and their videos, analyzing the overall social media engagement that they have, and monitors their revenue streams from sponsorships and merchandise. This unified platform helps optimize strategies to support their growth. We'll move on to business rules that will be explained by Ritika.
Thank you, Krisha. Now let's go over the business rules. First, let's look at the virtual idol relationships. Each idol has exactly one YouTube channel and performs only one live stream at a time. However, they can distribute content across multiple platforms and may use vocal changes as needed. Next, we have collaborations. Each virtual idol works closely with one painter who designs their virtual image and one motion capture specialist who brings these images to life with animations. Moving on to audience engagement, viewers can follow multiple YouTube channels, write reviews for content, and even participate in donations to support their favorite idols. These interactions are key to understanding viewer behavior. Finally, for live stream content, each stream can discuss one or more topics, giving idols the flexibility to engage with their audience on a variety of themes. Next, I'll hand it over to Prayag.
Yeah. Thank you. So basically, this is the entity relationship diagram. So this diagram is the comprehensive virtual content ecosystem, including a motion capture, virtual idol, and a YouTube live stream platform, as you can see on the left side of the screen. And so virtual idol is at the center, which is the core and representing this digital persona using the various entities. So it is linked with the virtual image, which is crafted by either the painter or the motion capture specialist with which assistance from the motion capture equipment, which is located at the top, and vocal changer for the additional feature like voice modulation and voice enhancing. So virtual idol operates on a platform such as a YouTube, where the activities are tracked by a YouTube channel and YouTube live stream, storing subscriber detail and live data stream data. Your YouTube live stream connects to multiple entities such as topic, which defines the theme of the stream, sponsor provide the financial backing, and their products are marked as merchandise. So viewer are the core part of the system where they can watch and leave reviews and also make the donations to the ongoing stream. The advertisement keeps on loading on the screen where the merchandise give the sponsorship and highlight their marketing value. And so this entire ecosystem is supported by the real person, which is the single entity linked to the YouTuber or the YouTube idol and linking the digital world to the real human operator. So next, database implementation will be presented by Advait.
Thank you, Blair. So in database implementation, first part is the table creation. So these tables on the screen represent the key components that go into building and managing a virtual idol. So in the virtual idol, you can see there are two main parts. One is the streamer and other is the virtual image. Now we have this streamer who is the real person, and we have this table to represent the streamer behind the idol. And the another part is the virtual image, which again consists of multiple parts. So they include the painters who design their appearance. Then there is a motion capture specialist who provide realistic movements, and the vocal changes, which handle voice modulation and filtering for the virtual idol. And together, all these tables form the backbone for the virtual idol creation process. Next is the data insertion. So here we have sample data inserted into tables we saw earlier. And this data includes details like the specialty styles of painters and motion capture specialists, the equipment brand and costs, and the personal details of real people who serve as the streamers. The importance of data insertion lies in the ensuring accurate and meaningful connections between these entities. For example, linking vocal changes to virtual idols ensures that right voice modulation settings are applied, while associating painters and motion capture specialists defines the idol's unique look and movement style. So this step brings all elements together, creating the framework for a cohesive virtual idol. And finally, this is the check constraint. So this slide explains one of the constraints we have implemented in database to maintain data integrity. So in the review table, there is a review type column, and this column is restricted to only specific values. Those are positive, negative, or average. And this ensures that all reviews entered into the system are consistent and valid, preventing any incorrect or unexpected data from being stored. And so constraints like these are essential to keeping the database reliable and consistent. So the next part is view report and encryption, which will be explained by Rina. Over to you, Rina.
Yeah, thank you, David. So here's how we created the wheels and the virtualization. First, we created two functions. The first, we need to calculate the time duration about introducing the advertisement during a live stream. And also we calculated the total donation amount during the live stream. And then we add these columns into the table, and we create a wheel called live stream information. And we can see the result. The result here. So we can see the virtual idols performance and also the profit all during the live stream. We import the data into the Power BI so we can get the virtualization of this wheel. The next wheel is the next slide. Thank you. The next wheel is the vertiverse image. So as what we can see in the slide, we can see the result. Yeah, the result is here. So we import the data into the Power BI so we can get we can know what virtual image and what types are most commonly used by the virtual idols, and also the painter styles or the capture equipment brands. Yeah, the next part is about the database encryption. We follow the encryption steps told by the professor. We encrypted the username in the where table, as what we can see in the left. There do have actual data in the username, but we can see it right now. When we decrypt the data, we can see the real name here. Yeah, and that's all about our project. We are ready to answer the questions. Thank you.
Oh, I have a quick question. Could you show us the ERD again? Thank you.
Yeah.
Yeah. Is it visible?
Yes, thank you. I would like to know in what kind of order did you guys design the whole system? Did you guys start with the VTubers themselves, or did you guys start in any other component?
Actually, we first created the virtual idol. And we think that the virtual idol it have a real person behind the virtual image and also the virtual image itself. So and also we focus on the live stream. So in this order, we create different entities related to them. Am I clear?
Yeah, thank you.
Thank you.
I have another question. Can you show the technique you use to encrypt the data?
Yeah, we encrypt the username in the viewer table.
So did you put the username first and encrypt everything, or you can encrypt everything that you insert?
Actually, we didn't consider about the inserting thing. We just encrypt all the username we have in the database.
Okay, so you just encrypted all the existing.
The existing data.
Okay, thank you.
Thank you.
Any more question, comment for team 2? Okay, great work and presentation from team 2. Your slides were great and your reports and visualizations were wonderful. And thank you for the questions. The questions were interesting.
Thank you, Professor.
Sure, of course, yeah. By the way, just a reminder, anyone can ask about any other team's presentation. Okay, keep this in mind. If you are interested in anything, you are welcome to ask a question about it. Let's welcome team 3.
Hello, Professor.
Yeah, you are on.
Yeah, let's welcome Eugene back for the first introduction part.
Okay. So hello everyone, this is Team 3. Our topic is gym operation and membership management system. So this is the introduction of our system. The purpose of the database is to maintain the data used to manage a training center's course arrangement and operations. And this system will be used by administrative staff to oversee course restrictions, scheduling, and resource allocation without duplicating information from other databases. And next is our ER diagram. So this diagram shows the relationships and interactions between 15 entities. Person is the fundamental entity storing common personal details, and member, instructor, and assistant use person ID as a foreign key to inherit basic personal information from person. And another important entity is course. Course and center is a many-to-one relationship, which means a course is conducted at a specific center, and a center can have multiple courses. And a course can have multiple sessions scheduled on different times. So course is also extended into two subtypes, which are public course and business course. Business course includes an attribute for tier, which helps to categorize courses by exclusivity, while public course is available to all members. And the last one is a business event entity. So it ensures that corporate events are effectively managed, and the combo entity allows tracking of nutritional content served during events. And that's all for the ERD.
Thank you. So for the next part, let me introduce the encrypted and decrypted of our database. Since we do not design a login system, we try to implement this feature in our person table. As you can see here, we encrypt our person's first name and last name here. When we insert data, it will automatically encrypt it and it will show a random character in our database. However, we also try to decrypted this data. So if you use this data SQL syntax here, you can get the correct first name and correct last name here. And we can also do this to our password and login the username of our users if there is a need. And due to the time limit, I will choose one important trigger in our system and the most important procedure in our system to introduce to you. And the trigger here is to check whether room capacity and to prevent overlapping sessions. Since when we are inserting a new sessions into our table, when we want to schedule a new one, this trigger will be triggered automatically to prevent overlapping sessions. We don't want to then there are multiple sessions in the same day, same time period, or the same classroom. So we will check the dates, classrooms, and the start times of new courses so that they can be placed in the appropriate schedule. And here's how we implemented this. The first thing here is to check the room capacity is greater than or equal to the session capacity. Since we want to every course to be in a room that is that is big enough to hold as many members as the course wants. And the second thing is to check the room is not occupied in the time period. There are multiple sessions are being taken in the same time, so we want to let the course to be distributedly take place in different rooms. And if all checks pass, we will insert a new session to the table. And here is our sample test. You can see here, we use our functions here, and we want to insert a session with session ID 14, the course ID 9, and we want to insert it to 2023 October 9th at 70 o'clock to room 9. However, you can see in our session, there's already a session named 9 at the same time, the same room, so it will show the error message. Another session is already scheduled in this room at the same time. So the test is successful, and we cannot insert the session into our session table. Yeah, let's welcome One, my teammates, to introduce the procedure part.
Yeah. Thank you, Juan. I will introduce one of our procedure. We want to a procedure to help us schedule course with some restrictions. So we create some parameters to execute this procedure. Next, this is the first check of the procedure. We want both the instructor and the assistant of this new course or session to be experienced, which means he must have instructed and assisted the same course before. And for the next check is to check if the time and the room assigned to this new course or session are not conflict with other existing course. After this procedure, we will do the insert to if all the check pass, insert all the necessary course information into the course table, and then it will automatically generate a new session code and insert the session information into the session table. Here is the sample test. You can see we give these parameters like the course ID, the course name, and the room ID, instructor ID, assistant ID. And we just execute this procedure to test it works. And for the view part, the first view is to provide detailed information about the courses, include the course ID, name, code, capacity, and descripted first and last name of both instructor and assistant associated with each course. It joins the course instructor, assistant, and the person table to combine relevant data into a single user-friendly format. And the other view is the detail of the restriction information for members, include the described first and last name, the course they registered for, and the course name. It combines the member person registration and course tables, make it easy to track member course association. And the next part is the visualization. The first visualization is the sum of the time by room ID. Because when the room uses many time, it needs to clean or change new room. So this visualization can tell us how many times the room was used. And the other sector diagram is the count of the course ID by years. It will tell us how many courses for each year we are already open for the people. And that's all about the visualization. So let's Yuting to introduce the next.
Hi. So
Sorry
our
to interrupt, guys. You are 8 minutes plus.
Okay, so hello, Professor. Are we allowed to just extend 1 minute to introduce?
Yeah, sure.
short
Yeah,
comments?
go ahead, please. Yeah.
Yeah, please. Yes, please go on.
Yeah, so far our code has demonstrated this very strong alignment with our original design document, covering core functionalities like person, roles, course, and session separation, and facility tracking. But there are still some critical gaps between compared to our original document. So for example, there are no constraints to prevent individual from being holding multiple roles. For example, a person can be the member and assistant and trainer at the same time, but also there are lack of dynamic checks for dietary needs. So next page, thanks. To address these shortcomings, we propose adding some constraint and session timing checks. Additionally, we will introduce corporate membership classification, enhance nutrition tracking, and enforce instructor center association. So finally, adding utility function for popular cost analysis and capacity tracking will ensure full alignment with our original logical design. So thank you. Do you have any questions?
About your encryption part. It's really interesting because it is a little bit different from what we learned before. Could you please explain it?
Yes, sure. A professor used to tell us two kinds of encrypt functions. The first is the varchar, and the other is the var binary type. We use the var binary type because if we use the varchar type, it will have some implicate type conversion, maybe cause unnecessary overhead or errors. And it also will reflect the actual storage form of encrypted data, which may cause maintenance confusions. Like when we select the person, it will give us the full name and last name empty. We don't know whether we have insert our first name or the last name successfully.
Okay, thank you.
I have a question. So for identifying the most popular courses or for calculating the remaining capacities, what kind of methods would you use to ensure the reports are accurate to check that it's efficient for the large data sets?
Yeah, for the large data sets, it will cost many time to select the aggregate data. So that's why we will use the views. We're using the indexed views to pre-aggregate data for popular queries, such as the cost suggestions, and it can improve the efficiency. Additionally, implementing schedule drop to update a summary table periodically ensures real-time performance without overloading the database during the peak times.
Okay, thank you.
Great work and presentation from Team 3. Your future enhancements were very interesting and great question. Thank you all. Let's welcome, of course, let's welcome Team 4.
Good morning, everyone. I'll be doing the introduction for Team 4's project entitled Online Shopping System. We're going to begin with a brief overview of our goals and purpose. Here's our table of contents. We set out to create a database that could efficiently manage inventory, customers, and order processing while ensuring data integrity and compliance. I included some key functions we focused on, such as tracking warehouse locations and inventory labels. Our goal was to support multiple teams, such as administrative, marketing, and sales teams, which handle customer and product data, and then to also support fulfillment and warehouse management teams to ensure smooth inventory operations. Next. Some of the business problems we addressed in line with our goals for this database were to allow customer service and marketing teams to access profiles for personalized support and targeted campaigns, focus on real-time access for orders and payments, track warehouse operations like stock levels, setting reorder points, and accessing product availability, focusing on warehouse selection to reduce shipping and delivery times, and to generate detailed sales reports and detailed stock data to better understand the business and improve relationships with suppliers.
And we have total 11 business rules. First, customers must have a unique email address to confirm their identity. Customers can have multiple address information that can be updated. They can have their shopping cart to store their desired product and reflect the up-to-date inventory level. Suppliers can have their product stored in warehouse and their inventory level will be reflected in the warehouse level. An order can be processed with at least one product and a valid payment. Each product must be assigned to one or more warehouse having their inventory level and their supplier information stored. The system will track inventory levels in each warehouse in real time. We can set a list of reordering thresholds. When all warehouse inventory for a product fall below the reorder threshold, a replenishment request can be made to the suppliers. When a return action are made, the system records the return reason, the customer and product information, and they can track the return shipment status. A coupon code can only be used for in-scope products. It will expire after a set of promotional period or become invalid once used. After a coupon is applied, the discounted price should be reflected on the order page before processing the payment.
We have 15 entities. Customer is the central entity. It stores essential information about customers, identified by customer ID as the primary key. It is the parent entity for other customer address and shopping cart item. Shopping cart item represents items that customers intend to purchase. It forms an identifying relationship between customer and product, where a composite primary key of customer ID and product ID represents items in the customer's cart. Order is a parent entity to order item payment. Order to payment is in a non-identifying one-to-one relationship, allowing payment records to be retained after an order is canceled. Order item is a bridge between order and product. It is also a parent entity for return and shipment. Product is parent entity for shopping cart item and order item. Product is also part of inventory in a non-identifying relationship with warehouse to manage inventory records of a single product in different warehouses, while supporting inventory updates without affecting product records. Warehouse is parent entity for inventory and return. Warehouse connects to supplier warehouse in a non-identifying relationship with suppliers. It's flexible to update supply chain information. Coupon customer represents an identifying relationship between coupons and customers, tracking discount usage. There's all information about DRD for our database design. Next slide.
Okay. This slide slide highlight three key aspects of SQL DTL statements, focusing on their roles in our database implementation. First, we will explore how computed columns are created using functions to automatically calculate values in a table. Next, we will cover views. And lastly, we will delve into the code-level data encryption, which can enhance security by protecting sensitive data in a database. These slides delve deeper into the topic of computed column based on the function. On the right, as you can see, the autumn column in the order item table can be automatically calculated by the quantity and multiple the price in the product table. As you can see, the autumn value were calculated automatically. And then move to the center. As you can see, the total amount equal to the sum of the amount in the order item table, which have same data ID, and the payment payment table, the actual paid amount equal to the total amount in the order table minus discount applied in the coupon table, and the discount amount, discount applied is calculated dynamically based on the predefined rules. This is a view that that can be supported work for supply chain employee and marketing employees. The first one is monitor the product with inventory levels at below or at the replenishment rules. As you can see, this product's quantity in stock level is below to reorder level, and it shows how many order they need to replace. This shows the performance of coupons. In this line, it shows the data encryption. As you can see, this is the password that our user inserts into our database. But when we show order data from the database, the password will like this.
Are we having some technical difficulty?
Sorry, can you hear me now?
Yeah, but it's still very low. Hunter, your voice is very low.
Okay.
Oh, sorry to interrupt, but the time is out.
Is this better?
It's low again, but you were loud. Just maybe speak up a little bit more.
Okay. Our first visualization is this word cloud here that indicates the common product and shipment issues that led to customers returning their products, where the color gradient and the size of the words indicate the frequency of cited return reasons. And then we can go to our next visualization now. Our second visualization looks at how people were paying for products. On figure X, the X-axis showcases the 3 allowed payment methods for our business: credit card, debit card, and PayPal, while the left side of the figure shows the total volume of purchases by each card. and the left shows the average volume of purchases by card. This information is important to the business as it helps determine policy of transaction fees for each payment method and can even help to detect what is often referred to as micro fraud, or the biggest indicator of which is when certain payment methods are frequently used to purchase very small orders.
Just to quickly go over some future improvements or future ideas we would like to implement, we'd like to optimize the database by further normalizing tables and strengthening entity relationships. We'd want to enhance security through multiple measures, including automating database backups. We'd also like to enable advanced reporting for trends, inventory, and seasonality analysis. We also did look into using geolocation data to optimize warehouse and customer fulfillment. To automate warehouse selection and add inventory alerts, and to prepare the system for seamless mobile integration. We're hoping that these enhancements would make the database more robust, scalable, and adaptable. And that concludes our presentation. Happy to answer any questions.
Oh, yeah. Does the application of coupons and promotional codes support complex rules such as combined discounts or dynamically adjusting the range of promotional products?
No, it is not supported. According to the business rule, a customer can only use one coupon per order. While we don't impose the restriction on the range of products, but we have set a minus spending requirement for product usage.
Thank you.
Well, one more question. How will you improve your encryption tactics and enhance the security of your database?
Yes, we'd look into implementing role-based access control, like assigning roles for administrators, operators, or viewers to limit the amount of access that they can, of the data that they can see. We also looked into storing passwords by hashing them, and to implement like login auditing, so it could capture the amount of failed login attempts to prevent hacking.
Oh, good idea. Oh, thank you.
Any other question, comment for Team 4? The teammates from Team 4 were from a different college. Is that a CHHS, right? Could someone from the team tell us about your college, your major, and where you are located?
Yes, we're from the College of Social Sciences and Humanities. We are all in the economics program, and we're all actually located in Seattle. We're from the same cohort.
Okay, are your specialization or concentration is on data science? Am I correct?
Yes, that's correct, Professor.
Yeah, excellent work and the presentation. The technical glitch didn't really affect your performance, okay? Great work, and thank you for the questions.
Thank you.
Of course, yeah, let's welcome Team 5.
Hi, Professor. Can you see my screen?
Yeah, you are on. Go ahead, please.
Hello everyone, we are group number 5 and our topic is gym management system. My name is Neil and my group mates are Uday, Liu, Sharon and Caroline. Next slide. So many gyms still relies on manual processing for registration and record keeping, which take lots of time and effort. Our system solves this problem by using computer-based approach. It makes things very faster and more organized. Staff can easily register their members and keep track of their details, even generate a report for a few clicks. This approach saves time, reduces paperwork, and makes work simple for everyone. Overall, the system helps gym to run more smoothly, save cost, and let the staff focus on providing better experience to customers. Next.
Okay, so as Neil discussed, there are multiple problems in managing data in the gym. So the solution for that is creating a centralized database. So we have created a comprehensive database system to streamline gym operations and provide real-time insights. And the another solution is creating the integrated system. Our system will generate the memberships for customers, classes, equipments, and also generate reports and receipts for the customer for the amount they have paid in the gym, and also create the monthly plan for them, and explain how to they work during their entire month and many other things. Next.
We have our design document here, and these are our tables. So first we have a members table where we store the gym members data, and then we have staff table for storing the staff data, and then we have the class table, and then next we have membership table, we have equipment table, payments table, and then attendance table for check-in and check-outs, class enrollment table, plan table for different plans offered. And then we thought we'll do something unique, and then we thought we'll have health status table, and then we have subscription table and the member goals table. Next. And then we have our ERD. I'll just talk about the important tables. So we have the plan table. A plan can have many subscriptions. A subscription references a specific plan through the plan ID. And then we have members table. A member can have multiple subscriptions. A member can make multiple payments. And then a member's attendance is tracked via the membership ID. And then a member can have multiple health status records, and then multiple classes, multiple fitness goals. And then we have the staff. Each class is assigned an instructor via instructor ID. And then we have staff table. Staff members maintains gym equipment. And then each class references a specific instructor via instructor ID. And then each class may require a certain equipment. And then the class table tracks the enrollment of members in classes via the class ID. Next.
Yes. I will show you how we built the database using SQL with two key tables as an example and a computed column we added to enhance the functionality. The member table on the left store essential information about gym members. It uses member ID as a primary key and link to memberships table through membership ID as a foreign key. This ensures that every member is allowed associated with a valid membership plan. The health status table on the right tracks a member's health-related data such as BMI, body fat percentage. It uses a member ID as a foreign key to link to the members table. We also added a computed column BMI statute that categorize members based on their BMI value. This makes it easier to analyze and track members' health. And we also created two wheels for reporting purpose. The wheel on the left is membership payments reports. Bring together data from the members, memberships, and payments table. By combining all this information, it provides a clear overview of each member's payment history and their membership plans, make it easier to track financial transactions and membership details. And the wheels on the right combines data from classes enrollments, and staff table. The view is grouped by class details and instructor name, making it useful tool for analyzing class participation, popularity, and instructor performance, helping to improve class scheduling and resource allocation.
In this slide is the total revenue by membership plan report. In this report, we have a pie chart illustrating the total revenue contributions from different membership plans. As we can see, the premium plan dominates the revenue, contributing a significant portion of the overall income. And the standard plan is the second popular. followed by the basic plan, which caters the members with minimal requirements. This visualization provides a clear understanding of which plans are driving the most revenue, enable management to focus on promoting high-performing plans or redesigning less popular ones. Next slide. This slide is the member payment report. This report provides a detailed table summarizing member payment details. It includes the member ID and the name, the type of membership they hold, and the total amount they have paid. The summary at the bottom shows the total revenue generated, and which aligns with the data visualizer earlier. This detailed breakdown helps ensure transparency and accuracy in financial reporting. Next one. In this slide is the class enrollment report. Finally, the bar chart displays an overview of class enrollments, which is classified by instructor name. We can see the most popular class are at the top, instructed by Tom and followed by Chris, indicating which instructors are more popular with clients and which ones are not. This allows management to optimize resource allocation by prioritizing highly popular instructors, ensuring members' needs are met efficiently. That's all. Thank you.
Any questions, please?
Yes, very good presentation. For the prior slide, you kind of touched on it, but what business insights do you hope to draw from the visualization for total class enrollments, and then you filtered by instructor's first name? This visualization makes it easier to evaluate instructors' performance and further adjust their bonus and class schedule based on the demand of the clients. Further, the management will enhance the gym's operational efficiency. Thank you.
Our second question can be, how would you want to alter or add to the database in order to scale up the business operation?
Okay, thank you for asking. We can do that with several aspects, like adding new tables to support the new service, like online classes or equipment rental. And we can also updating the existing table, like adding new fields to store extra information, like a referral source in the members table. And at last, we can also support multiple locations, like add a field or table to track different gym branches if the banners expand to new locations. Thank you.
Thank you. Nice design.
Great work and presentation from Team 5. Thank you, Team 5. And the questions were very interesting. Great question. Thank you. Let's welcome Team 6.
Hi, Professor. I cannot share my screen now.
Oh, do we have to maybe team 4 or Team 5 stop sharing, please?
Okay. Thank you.
Professor, we are ready.
Okay, yeah, go ahead, please, Team 6.
Hello, everyone. Today, we are excited to present our project, MoneyMate, a personal finance management system. We are Team 6, and our mission is to simplify financial management with an all-in-one solution. Here is Next page, please. Here is the outline of our presentation, which will be divided into 4 main sections. Let's start by looking at the key challenges we address. We found that managing personal finances can be overwhelming. Many of us deal with multiple accounts across different banks and currencies, making it hard to keep track. Without clear tools, it's easy to overspend or missing a repayment date. That's why we create MoneyMate. It gives you a clear overview of your finances. With visual reports, you can easily understand your spending and budgeting, and smart notifications remind you about low repayments or budget limits. And you can even attach receipt to keep your records complete. We believe MoneyMate can make financial management much more easier. Our database is built following third normal form principles. Here's our entity relationship diagram showing how those modules connect. Foreign key constraints define relationships between key modules like users, accounts, budgets, transactions, and loans. We've also added features like notifications and file attachment to enhance functionality. This design makes MoneyMate reliable and ready to grow. And next, let's take a look at the technology behind MoneyMate.
I will explain data validation and initialization part from 3 aspects. First, table level check constraints. A table level check constraint has been added using a function to ensure that expense transactions do not exceed the associated account balance. Next, please. Using triggers for automated data processing. These 2 triggers automatically update the account balance when a transaction or loan-related action is recorded. The first trigger handles loan-related transactions, updating the balance based on transaction type, increasing it for borrowing and received repayments, and decreasing it for user repayments and lending. The second trigger adjusts the balance after transactions inserted, increasing it for income transactions and decreasing for expense transactions. Next, please. Data insertion. For most of the tables, we use direct data insertion. For more complex operations, such as transferring funds between accounts, we use stored procedures. The stored procedure transfer funds handles the logic for ensuring sufficient balance, updating the relevant accounts, and maintaining transaction integrity. It demonstrates a more dynamic approach to data insertion. Next, we will move on to the view section of the database.
The first view we made is monthly financial summary. We use Tableau to visualize the data, so it'll be easier to understand monthly trends in expense, income, and net savings. As we can see from this picture, the blue color presents expense, the orange one is income, and the red one is net savings. Next, please. To calculate data, we utilize 2 common table expressions, income CTE and expense CTE. They calculate total income or expenses per month by selecting transactions with transaction type ID equals to 1 or 2 for the year 2024. Sorry. Next, please. We also designed a function called calculate net savings. It computes net savings by subtracting expense column from the income column. And then for the view, we combine income and expense data using a full outer join and get computed net savings using the calculate net savings function. That's all of the monthly financial summary view. And the next view is monthly spending summary.
So here for the monthly spending summary, we use this view to display monthly expenses for the year 2024 across different categories. For example, you have grocery, utility, and entertainment. So you can see here on the visualization part, we use lines with different colors to represent specific spending category. So in that case, we can see like monthly spending changes on specific category more clearly.
So here we have the category spending CTE, which calculates monthly spending by category. We use the month transaction date to extract the month from transaction date. Then we use the sum to aggregate the total spending per category and month. And here we have the pivoted data CTE, which pivots spending data from rows into columns for each category. We use sum to conditionally aggregate the spending for each category, and we use the left join to combine all months CTE with category spending CTE to include all months. And here for the final output query, it formats the months into year and month format. So it fills any missing values with 0 using the correlates. And this view helps to our users to track spending pattern, identifying the overspending and plan budget effectively. So by providing this consistent and complete data set, it supports accurate financial analysis and better decision making.
Okay, let me summarize our working process. During the design phase, we initially struggled in identifying and not identifying relationships. But with feedback from our professor and TAs, we refined our design. Implementation and integration went smoothly as each step built on the previous one. Testing, however, was unexpectedly challenging, but it also brought a significant improvement to our project. For example, we discovered that enforcing check constraints on transfer and transfer account caused redundant data issues, which could potentially affect database efficiency, even though the data accuracy was not impacted. We resolved it by implementing transactions to maintain consistency while reducing redundancies. This approach ensures both performance optimization and logical accuracy. We also worked to balance cross requirements with business needs, but also due to some constraints, some features were still simplified in this database design, like loan interest calculations. That's all from us. Thank you for listening, and we'll be happy to answer any questions.
Thank you for presenting. I do have a question. Can you explain how you use the constraints like track or other methods to maintain the logical integrity of your data?
Sure. Thank you for asking. To maintain data integrity, we use the constraints and triggers. For example, in the loan table, we use a check constraint ensures that the due date is always later than the loan date, and users, and also in the account table, users cannot create multiple accounts with the same name. And we also use foreign keys to link tables, like tying each account in account table to a valid user in a user table, ensuring consistent relationships. For more complex rules, we added triggers. For example, account balances update automatically after a transaction, like the income increases the balance and the expenses decrease it. And we think these are the methods we use to make our data stays accurate and reliable.
Okay, that's pretty clear. Thank you.
I have another question. During the transfer process, how do you ensure data consistency between the two accounts?
Thanks for your question, and I will answer it. So to ensure data consistency during the transfer process, we use the transaction to bind that all the related operations together, like the updating balance from both source account and the target account. In this way, either all operations success or any of this step failed, everything goes back or to maintain consistency. For example, if we added balance validation to check for the funds and use the error handling to capture issues to roll back if needed. So if one of these steps failed, all data will roll back and keep its consistency. This approach ensures that all the transfer and the transfer account remain consistent and reliable throughout the transfer process. That's my answer. Hope this makes sense for you.
Yes, thank you.
Thank you.
Great design and presentation from Team 6. Thank you, Team 6. And great and interesting questions. Thank you.
Thank you, Professor.
Of course, yeah. Let's welcome Team 7.
Hello everyone, we're on Team 7, and our topic is database design for API management platform. Next. So the API management platform simplify API usage by tracking codes, managing subscriptions, and handling payments. It ensures accurate billing, smooth user experience, and seamless transaction management. And for key design decisions, our database design include entities like users, plans, APIs, and developers, connect through relationships such as user plan history and payment tracking. Additionally, relationships like API to version referrals and developer to revenue associations offer insight into performance and facilitate future planning as well. And for business roles and features, the platform enforce rules like unique account, non-negative balance, and mandatory API developer links. It supports multiple payment methods, positive transaction validations, and users' feedback for APIs. It ensures quality, reliability, and efficient API management. Next, please.
This is our ERD. The user module is the foundation of the system, storing user account details like username, password, and balance. The plan module defines different server plans, such as fees, call limits, and durations. User subscriptions are logged in the user plan history, which keeps track of start and end dates. The payment module handles user payment methods, like credit card details, and tracks payments through the payment referral table. The API module is closely tied to the developer module, storing API details, versioning, and call logs, along with developer information. The review module allows users to rate and provide feedback on APIs. Finally, the revenue module tracks the platform's earnings and links them to developers and payment records for better management. Next one, please.
In this section, we'll dive into the implementation of the database. For data creation, we've started by defining foundational tables first, which had simple structures with primary keys, such as the plans table on the left. And after that, we created associative and transactional tables, which require handling of foreign key dependencies, such as user plan history on the right as an example. Next, please. For key constraints, we implemented 6 key track constraints to ensure data validity across the database, including user balances, API status, review ratings, subscription periods, and transaction amounts. Next. Let's look at 2 examples. Firstly, for a balance constraint, it validates that user balances are non-active. This is achieved using the check balance function and the CK users balance constraint on the user table. The second example is API status constraints. It ensures the status column in the API table only accepts valid values like active, inactive, and deprecated. And this is implemented using the check API status function and the CK API status constraint. Next slide. Once the tables were created, we implemented the data insertion following a sequence that ensured referential integrity. For example, we inserted data into plans first to populate available subscription tiers, and after that, we inserted users' records that reference those plans. Next, please. For the views, we have implemented 3 views to streamline commonly required queries. The first view is user plan details. It provides a consolidated view of user subscription details, including their accounts balance, subscription, start and end times, and associated plan details like name, fee, and duration. And it simplifies querying user plan relationships by joining the user plan history, user, and plans table. And this view is particularly useful for customer support and financial tracking. Next, please. The second view is the developer API call summary. It aggregates API usage data for each developer and combines information from the developer API and API calls table. And it shows the total number of calls for each API. And this is useful for developers to monitor API performance and identifying high demand services. Next. The third view is the user payment details. It consolidates payment information for users and combines data from the payment referral, payment method, transaction, user tables. And this view allows administrators to quickly access user payment history, including transactional amounts, billing addresses, and card information. Next.
For the part 4 column data encryption, we secured a password stored in the user table. This approach leverages SQL Server's built-in functions combined with the store procedures and the triggers to automate the process. To begin, the master key secures the entire encryption, while the symmetric key handles the actual encryption and the decryption using the AES 256 algorithm. For the encryption process, we developed a store procedure to encrypt plain text passwords using the encrypt by key function and output the encrypted binary value. Next slide, please. Also, we utilize a trigger to ensure that all the passwords inserted into the user table are encrypted automatically. Next slide, please. Similarly, we implemented another procedure to decrypt the binary password back into the plain text when needed, such as the validation or another scenarios. Next one, please.
Okay, so I will introduce our 3 key visualization we have generated from our database. So the first chart illustrates the average rating of various APIs in our system. As we can see, list subscription stand out with a perfect score of 5.0, indicating excellent performance and user satisfaction. Other APIs like add product and get user info also score high at 4.5. On the lower end, the lead product has the lowest rating of 2.8, suggesting room for improvement in functionality or usability. And the second chart captures the trends in API usage over time. While the usage fluctuates, there are noticeable peaks, particularly on day 8 and 13, with call volumes reaching above 1,600. These spikes may correlate with specific events, promotions, or user behaviors, which deserve further analysis to optimize API performance and scale efficiently. And the last, we have a pie chart showing case the top 5 developers contributing to revenue. Among them, the ELEF Coders 10 leads with a 15.53 of the revenue, followed closely by Byte Builders S5 at 14.12. And this chart highlights the significant impact of a few key contributors on our platform success and provides a strategic focus for collaboration and rewards. That's all for our presentation. Thanks for watching.
Yeah, thanks for your presentation. And I have a question. So could you explain how your data structure support for future scalability, such as adding new features or handling more complex queries?
Okay, thanks for asking. So our database actually use a normalized schema to minimize the redundancy and establish clear relationship between tables like user, plans, and API. we have features such as foreign keys constraints to ensure data integrity, while modular design with views and functions allows for easy update and future feature expansion.
Thanks for your answer. It's very clear.
My second question is, what are the trade-offs of using semantic encryption for sensitive fields like a password?
Hi, thank you for asking question. So the symmetric encryption, it can ensure faster encryption and decryption and simple key management within the database, but requires strict control of the encryption key to avoid the breaches, such as the master key we implement in our design. And the asymmetric key encryption, it can provide more secure key management, but introduce higher computation overhead and much complexity. So that's my question.
Thank you for answering.
Great work and presentation from Team 7. Your slides were great and interesting question. Thank you. Let's welcome Team 8.
Professor, can we start now? Professor, can we start now?
Yeah, sure. Yeah, of course.
Okay. Hi, everyone. We are Group 8 presenting our chain hotel database management. Here's the agenda. I will start with the business context and ERD, and my teammate will dive into the technical parts. Next slide, please. Many of us just returned from Thanksgiving vacation. Think about your hotel stay. You booked a room online, checked in, checked out, paid the bill, and then left. Our database is designed to manage all of this data for chain hotels. The primary users are hotel staff and management. And let's take a quick look at the business rules. Then we'll see how they're implemented in the ERD. Next page, please. And our database includes 16 entities. Let's group them into 3 parts: the hotel management, the room management, and reservation management. For the hotel management, I created a flowchart showing the hierarchy between hotels, department, and employees. We also use department type to categorize standard departments like front desk and housekeeping, plus optional ones such as bar or fitness. This ensures consistent management within the group. And for the room management, the logic is similar. This table shows how rates differ by hotel and room type. The room rates entity makes it easier to track and adjust prices, especially when users want to adjust them seasonally. And finally, the reservation entity is the core system. The reservation entity records check-in, check-out dates, and status ID. We use associative entities to handle many-to-many relationships, including the one that tracks room availability through triggers. And my teammate will explain this in more detail shortly. Now I will hand it over to Jiahui for the database schema.
Thanks, Zhe. We created tables per ERD. Each table has primary key and some have foreign key. Hotel management information is shown by this table. The hotel table uniquely identifies the hotel using hotel ID. We use int type for primary key so it could increment by itself. Next, please. We create table to manage room information. Table room rates is linked to hotel and room type through foreign keys, while using a composite primary key to check room rate for specific room types in different hotels. We use cluster for primary key because range query over them are faster due to sorted storage. Next, please. The remaining table use same technique to create, so we take a quick look on them. Here is the reservation tables. Next, please. Here is the guest management tables. Next. Here is the bill status and bill payment tables. Next. About data insertion, we insert more than 400 guests, 300 reservations, and 100 rooms. Now, my team member, when you will introduce life cycle or reservation, Dex.
Thanks, Jiahui. Let's take a look at a typical life cycle of a reservation. The first step in making reservation is to find a room. We'll need user input such as hotel you want to stay in, the room type you prefer, and your check-in and check-out dates. Then we'll query the room table joined with the occupation table to get a list of all the available rooms that fit your needs. Now that we have a list of rooms, let's pick one and make reservation. Since there could be a time gap between finding a room and making a reservation, we've added a table-level constraint to avoid any time conflicts. Before we can insert or update data in the reservation table, we'll query the room occupation date table to check whether this specific room is occupied within the guest's desired time window. If there is a time conflict for that room, we'll deny the insert or update. If any data is successfully changed, a trigger will write or delete the corresponding room ID and occupation date record in the occupation date table, maintaining accurate status for each room on every day for easier future querying. And after a reservation is made, employees can perform check-in and check-out operations by updating the reservation status. When the status changes to checked out, the system will automatically generate a bill. To calculate the bill, we'll retrieve the hotel ID and room type ID, use the room ID, and find the room rates for this particular room, and calculate the night counts using the check-in date and check-out date. And finally, the total price column will be a calculated column equals night count times room rates. When the bill is generated, its status will default to unpaid. Once the user pays the bill, which means inserting a new record into the payment table, the system will update the corresponding bill status to paid. This is a simple walkthrough of our reservation management process. Let's move on to the view and visualization part with Wenting.
Okay, thanks for Wenyu. And now let's go through the part of view implementation and visualization. For the reservation, we have built two views to check the occupancy rate of each hotel of both last week and in the next week. Next, please. We've also built a view to make an every week assessment to each hotel based on occupancy rate, income, and guest grading in the last week. Next. For the visualization, we draw a bar chart to visualize the book rates of each hotel in the last week and next week. We can adjust the bar on the top to view the occupation rate of a specific date range. We can compare last week's occupancy rate with the current week. Take the DoubleTree Boston as example. Its occupancy rate in last week is 25%, while this week is 80%. We can tell which hotel is doing better than last week and which hotel still have some gap to fill. Next, please. Here is the visualization of each hotel's daily income last week and payment method distribution. And next, please. And here is the rating of hotels indicating which hotel has the best performance in the last week. Managers can monitor the hotel's ratings and take actions to hotels which got a low rate. Next, please. And the last is the visualization of the changing of occupation rate from last week to the next week. The chart indicates that the occupancy rate is obviously higher in weekend than weekdays and exhibits cyclical patterns. It can be used to observe and predict the trends in hotel bookings and helps making business strategies. That's all of our presentation, and we are welcome for any questions. Thank you.
The first question is, what will happen if one guest wants to extend their reservation?
Yeah, thanks for the question. Let's jump to the page that explain this. Yeah, so when a customer wants to extend his stay, for example, he want to stay for 2 more days, and we can try to update the data in the reservation table. We will get his reservation ID and use this ID to update the checkout date by 2 days towards. And when we try to update the data, there is a table level check constraint to check the room availability. We will see whether this room is occupied for the next 2 days. If the room is occupied, we can't update this record, so it will fail. And then we will have to let this customer to change to another room and book to this for his future stay. And if this room is not occupied, so we can update the data successfully, then the trigger will be triggered to delete the old information about his room occupation date from the occupation table and insert the new insert a new room occupation date into the table. And so this way we can maintain the room occupation date table to stay accurate. Yeah, thank you. Hope this explains.
Thanks for answering. My second question is, how do you calculate ratings of each hotel?
Yes, thank you for the question. The rating of each hotel is calculated by the total income in the last week, the occupancy rate in the last week, and these two data are normalized into range 1 to 5, and then they will be calculated as the weighted average with the rating of the guest. I hope it can answer your questions.
Yeah, great answer. Thank you.
Great design and presentation from Team 8. Your slides were wonderful and great question. Thank you. Let's welcome Team 9. By the way, thank you for your help. We are doing well with time. We are probably halfway through the presentation. And, it's a team effort to keep the timing on track.
Hello.
Yeah, you are on.
Okay. Anvita, ready? Yeah, can you just do the slideshow, please? Yeah, okay. Welcome, everyone. We are group number 9, and I'm Anvita, and I'm excited to introduce our project, that's Project Management Database System. This is a solution that revolutionizes project management and boosts organizational efficiency. This is a centralized platform for real-time project tracking, planning, and execution. It streamlines tasks, sets milestones, and facilitates better decision-making across departments, ensuring we effectively meet project requirements and priorities. Now let's quickly run through the key business problems that our database system addresses. It manages roles and permissions to prevent any unauthorized actions, provides clear accountability as client and projects are linked within the system, optimizes task management to prevent bottlenecks, streamlines approval processes, ensures accurate document tracking, ensures precise work time logging, enforces task timelines, notifies of expiring contracts to prevent legal or service issues, facilitates timely invoicing to maintain a smooth cash flow. By addressing these issues, our PMDS optimizes outcomes, increases productivity, and helps achieve strategic goals efficiently. Now I'll hand over to my team member, Royu, who will explain the crucial business rules governing our project management database system.
Thank you, Avinta. Here is an overview of our business rules. Starting with user requirements, every user belongs to a department managed by one department manager. Each user must have at least one role to define their system access. For client requirements, valid contact information is essential for assigning clients to a new project and for future reliable communication. Moving to project proposals, proposals must connect to a client, include documents, and have a budget plan. Projects are only created after the proposal completes the approval process. Once approved, each project is assigned a project manager, a team of members, and can include multiple milestones, which are always tied to their project. Next, onto task management. Milestones contain tasks, and every task is tied to a milestone. Tasks must have an owner and cannot be edited without a formal change request. For issues, they need a proponent and can be transferred to tasks afterwards. However, acceptance requests cannot proceed until all tasks and milestones are completed and all issues resolved. Finally, every approval process is tied to a project proposal, acceptance request, or change request. Notifications are linked to approval processes and tasks to ensure everyone stays informed. Together, these rules created a structured and efficient system for managing users, clients, projects, and their components. Now I'll hand it over to Sithan for the entity description.
Thank you. In our enterprise system, the user entity represents individuals such as project managers and team members who manage and execute tasks. Each project serves a certain entity, capturing essential details like clients, managers, milestones, tasks, budgets, connecting to related entities like proposals and change requests. A project proposal records the initial submission of new ideas or plans, while the milestone tracks the key stages of a project, helping us monitor progress. Task represents individual work items linked to milestone owners and statuses. The client entity captures external client or organization detail for tracking project requirements, contacts, priorities, while budget helps allocating financial resources and access project feasibility. Next, we have the role entity defines user permission responsibilities, and department information supports organization structure, permissions, and project ownership. To ensure control, the approval process manages decisions for changes, proposals, and tasks, while notifications keep user informed about events like approvals and tasks. The issue entity tracks and resolves problems through the project lifecycle. The document entity stores key projects such as contracts, design, meeting rules, and the resource entity helps to manage tools and assets needed for execution. Together, these entities enable streamlined project management and collaboration. Now I'd like to call Mark to explain further.
Yeah, thank you, Silen. It's kind of small here. So ERD shows the structure of our PMIs, and as you can see, it's kind of complex. The user entity at the top is like the foundation of our system. It connects with roles and departments, supporting user authorization and the permission checks. Since it's a project management system, project entity is at the center of our ERD. As you can see, it has all sorts of information of relationships with other entities, and the projects are managed at different levels, from high-level milestones down to individual tasks. Also, we have notification, issues, and change requests allow for effective communication and issue tracking throughout the project lifecycle. In addition, the approval process and acceptance request entities provide a structured way to manage approvals and ensure accountability. Finally, we are employing associated entities like this one here, the user project entity, to demonstrate the many-to-many relationship between different entities. Now I'm handling this to Kisana for table creation.
Thank you, Mark. Entities such as project user and roles have been created by appropriately assigning the primary keys and defining suitable data types for all attributes. Additionally, foreign key references have been established for relevant attributes in each entity. An additional computed column known as total stock cost has been included in the resource entity, which has been used to calculate display cost of each resource individually. Triggers and table constraints have been implemented to enforce business rules and streamline the process of updating multiple tables. So one such example for trigger is which is implemented on the approval process entity such a way that the approval status in the budget and the project proposal is updated as the approval status in the approval process table is been updated. These are a few more examples of the triggers. Now moving on to the table check constraint. This enforces the business rule that the projects are generated upon completion of approval process of project proposal, and hence it works on it. Considering the table structure, multiple values have been added into the entities. Specifically, the password attribute in the project user entity is encrypted using the hashbytes function, which in turn runs on an SHA-256 algorithm. Now moving on to Mark for the views.
Sure. So we have 3 views for this project. The first one is like a view for project status. Basically, what it does is to collect data from the project table and group it by status. Can we move to next slide, please? As you can see, so we can easily see the distribution of projects in different status in this view. And the second view is a comprehensive view of all projects. Next slide, please. So it shows all projects milestones and associated tasks. It's like an information center for our project with assistance of filters where I can easily get the information.
Sorry to interrupt, but time's up.
Okay, so let's move to the next slide, and it's real quick. Yeah, it's like a slide to say both the change request and the approval status, and most importantly, we can easily track the feedback from the supervisors in this view. Next slide, please. And now, we are in the final part.
Okay, now moving on to the visualization. This whole summarize the project data. The bar chart on the left compares the number of tasks and milestone across projects, while the right bar chart highlights the budget allocation for every project proposal ID. The pie chart shows the count of project in various project statuses such as active, accepted, completed, from which most projects are marked as active. Together, they provide a clear view of project progress, workload, and resources. Thank you all for your attention, TA team for the guidance, and Professor for this wonderful opportunity. We are open to questions and answers.
Thanks to the presentation, I have one question about the approval process. Did you have a mechanism to make sure only the authorized user can approve the change of task owner? Thank you.
Yes, so we have in the approval process, just a second. Okay, so in the approval process table, we have someone known as approver. So that person is also a mandatory person who has to approve every approval process, and then is the approval process being correctly recorded in the table.
Yeah, thank you.
Thank you.
Great work and presentation from Team 9. Thank you, Team 9, and thank you for the question. Great question. Let's welcome Team 10. Team 10, you are up next.
Yes, Professor.
Hi, good morning, everyone. We are Team 10, and today we are excited to present our project, the Restaurant Management System. And the restaurant often struggle with the issues like poor inventory management and mistakes in orders and reservations, and the lack of tools to analyze sales and customer preference. And those problems increase the cost and reduce customers' satisfactions. And our goal was to create a centralized database to simplify operations, automate tasks, and enhance customers' experience with a personalized service and loyalty program. And our system includes 18 connected tables, each handling a special part of the restaurant operations, and together they ensure everything works smoothly and efficiently. And next, we will highlight some core features of our database. And by the way, to give you a better understanding of our structures, we have included the ERD that shows how the tables are related, and this diagrams highlights the key connections that enable seamless integration across the system. Our database is able to track the customer's profiles, preference, and loyalty points, and process orders efficiently, assign staff, and apply possible promotional discounts, and manage inventories to prevent stock issues and ensure the food safety, and track payments for the financial clarity, and also updates menus in real time. Also supports delivery tracking and also generate actionable insights from the sales and the customer data.
And let me share some key highlights of our program. First, we have a key feature, highly automated deployment. This design reduces human intervention and the chance for mistakes while making teamwork and real-world applications easier. Deployment becomes simple and reliable in both development and production environments. Next is our innovative design, the loyalty management system. This design not only fits the actual business logic, but also enhances the system's business value. For example, by managing customer loyalty, organizations can market more effectively and improve customer retention and satisfaction. Imagine a restaurant manager who can say each customer's loyalty level in real time and provide more suitable service. Finally, we have developed a system architecture that is designed to scale. This flexible design allows our system to adapt to various business needs and providing long-term support and value to the organization.
So imagine a busy restaurant where reservations are very essential, but too many tables are reserved. Walk-in customers might not have a place to dine in, so this impacts not only customer experience, but also the restaurant operational balance. So we wrote a function that checks if the number of reserved tables stays between 1 and 20. And then we add a check constraints to the reservation table to enforce this rule automatically. And here are two, it's successful case, reservation 10 tables works fine. And here is 4 case because trying to reserve 25 tables failed due to the constraints. And the next, now we are moved to another challenge. If a restaurant processes too many orders in one day, the staff might be overwhelmed, lead to physical strain and disruptions to daily operations. To avoid this, we need to cap daily orders at 1,000. So we create a function to count the total orders for a specific date and validate it under the limit. And then we apply this function as a check constraint to the order table. And we are showing the text result. The first one is success when we insert 1,000 order for a single day. The system allows it. And this is another false case because order because showing the system enforce the rule.
Okay, in our database design, we implemented a dynamic loyalty level system for customers. This achieved using a computed column based on a customer function called getLoyaltyLevel. The function evaluates a customer's loyalty points and assigns them a tier: bronze for less than 50 points, silver for 50 to 149 points, gold for 150 to 249 points, and platinum for 250 and more points. This loyalty level is calculated dynamically and does not require manual updates. Here is a query result showing the loyalty level dynamically calculated for our sample customers. This design allows the system to provide real-time updates to loyalty levels as points change, enhancing both usability and efficiency.
And following are 3 key insights from our restaurant management system. These charts provide an overview for customer loyalty, rating distribution, and menu item sales percentage, offering valuable insights into customer behavior and operational performance. Let's start with the first chart. This is a pie chart showing that distribution of customer loyalty levels. As you can see, this breakdown helps us understand our customer base better and refine our loyalty program to encourage more engagement. The second chart shows that the distribution of the customer rating. From this bar chart, we can see that most customers are very satisfied with our services. However, there are a few lower rating which highlight areas for improvement in our operations. The third chart presents the sales percentage of menu items in the pie chart, and as we can see, this data enables us to adjust our menu and marketing efforts to maximize revenue. So this analysis gives us a clear picture of how we can improve customer satisfaction and optimize our restaurant's performance. So thank you for listening, and if you have any questions, please feel free to ask.
Hello, I have a question.
Yeah.
So this customer loyalty, I mean the points which you gave, the bronze, platinum, and gold. So how is it determined? Is it determined by the number of reservations or the number of order value?
Actually, this loyalty level is based on the how much money you spend in the restaurant. We account $1 as 1 point. So like how much you spend, and it will account your points. Yeah, thank you.
Okay.
Great work, great design, and great presentation from Team 10. Thank you, Team 10, and thank you for the question. Let's welcome Team 11.
Yes, thank you, Professor. 1 second, I'll share my screen.
Take your time, yeah.
And 1 second, let me enable this to share to. Okay, yes. Yes, so we can start. Hi,
Go ahead, please,
everyone.
Tasha. Yeah.
Hi, everyone. Our team is Team 11. Myself, Darshan Gohil, and today we will be presenting our DMDD final project, which is based on financial services of centralizing the entire bank and financial services sector, which is called Bank Hub. So we saw when we choosing our mission statement and design problem statement, we saw that a lot of customers faced handling multiple applications, multiple websites to get used to or get track of their financial products. There are so many complex compliance mechanism which the user is at times not aware of, and at times he might be very inefficient to track each one of them. There is, on top of that, there is no centralized comparison platform for comparing products each of the bank offers. And to sum it up all, there was very lack of awareness for all the products that each of the banks offer. To tackle each of this and create a very centralized and combine all of them into one, what we did is we created Bank Hub. The sole purpose of Bank Hub is to make sure that we centralized all the banking operations, be it your customer account, be it your trading account, be it your credit account, debit account, anything. We also integrated government agencies in order to ensure and enforce financial compliance. Because at times there might be some banks who, just in case, might not follow the regulations or might not disclose it to its customer. To make it very transparent to user, we created some of the firm business rules and decisions such that all the customers are managed effectively and efficiently. We don't want the data to get corrupted, so we created proper relationship with the beneficiaries for transactions. We created an exact replica of the banking system that exists in real world, and in order to ensure we follow all the compliance and regulations. Sagar will go ahead after this for design principles and design.
Thank you, Darshan. Taking into account all the business objectives and requirements, we have implemented the ERD at a very granular level. As you can see, we have four main entities, which are federal government, bank, and customers. So all these are implemented as a very granular level, starting from the federal bank. Federal bank monitors all the bank operations of each bank in the system. Bank is one of the main entities of financial institutions that offer many product services, which are highlighted in yellow, which are like credit cards, current accounts, savings account, and all. In order to map the relationship between the bank and the products, in the third normal form, which addresses the many-to-many relationships, we have implemented the associative tables, which are highlighted in pink. Now, coming into customers, in order for customers to use the banking product, he needs to be linked to the bank using this associative table. A customer can have in accounts or product services in many of the banks, and a customer can also subscribe to many of the products. In order to map the relationship between the customer and the products, we have implemented this associative tables, which takes care of all the relationship and normalization in the ERD. Also, to track the transactions of each customer having different products and customer accounts, we have implemented the transaction history, which keeps track of all the balances and transactions of each customer. To keep security point of view, and we have also implemented security log, which takes into tracks every activity of the customer. And there's also lastly a beneficiary entity, which maps all the customers' transactions to other customers. Now, coming into implementing the database in the real world. So we have used the data definition language to implement the key tables like bank, customer, and card, and beneficiary. Now, coming into the next part, data insertions. So we have populated these tables based on the real world example, taking into account the granularity for each data that we have inserted. Now, going into next, we have also implemented triggers, which will enable to track the customer balance for each transaction from each account the user has. Also, in order to generate a beneficiary ID, that is when a customer is sending data to sending payment to another customer, it needs to auto generate a beneficiary ID starting from Ben and 001. So in order for all to check the table level constraints, Anusha will explain further on.
Thank you, Sagar. So to enforce data integrity, we created table level check constraints. As Sagar mentioned in create table slide, in order to enforce check constraints, we use table level check constraints using functions. So here, few of the check constraints are validate email. So to validate email, we have to see that the email contains @ and the email should be valid. Validate amount. Suppose whenever a member or a customer is transferring money to another account, the amount he or she is transferring should be greater than 0. The other constraints are validate phone number, validate city. The phone number should contain digits and should be equal to 10. And the validate city should contain only alphabets. Encryption and decryption. So we use encryption, decryption to mask data. Here we encrypted IP address in security log table. In our project, the security log table are used by banks to monitor suspicious activity such as failed logins, unusual locations, and unauthorized access. So by encrypting IP address, we safeguard customer identity and location details. So this ensures even if the database is breached, IP address remains unreadable without decryption key. SQL views. This view is transaction history of customers across banks so that customer can track to whom the money was sent and why it was sent. So this view gives clear summary of transaction history and is also includes beneficiary information. So it makes easier for analyzing the financial transactions. So the next slides will be taken over by Nikhil.
Thank you, Anusha. This SQL view is designed to help customers track and analyze their average monthly debit transactions, providing valuable financial insights. This helps the customer identify their spending patterns, monitor trends, and make informed financial decisions. It supports budgeting and planning by giving a clear view of where their money goes each month. Therefore, it is a powerful tool for customers' engagement and also helps customers with financial awareness. Next, coming to analysis using Power BI, we ingested data from the tables into Power BI by connecting it to the database directly. Here we can see that here we see the customer concentration across all the cities in the entire USA. This information helps bank launch their campaigns and focus their efforts on where there are chances of having greater success and better customer service. The next slide provides an overview of customers' monthly spending patterns, number of transactions, and distribution of spending across different months. The top left graph illustrates the average amount spent per month, highlighting key trends which would help a customer plan his expenses so that he is financially fit. In conclusion, our centralized relational banking database addresses the challenges of fragmented financial data by offering seamless customer access, streamlined data aggregation for banks, and enhanced government oversight. Built in third normal form, it ensures data integrity, scalability, and robustness, which are the key qualities for modern banking. This concludes our presentation. Thank you.
Thanks for presenting. Can I ask one question? And what does the SQL view show for each account?
Yes. 1 second. Let me go back. Yeah, so we actually created 10 to 12 views for this, but we have only mentioned 2 which were fitting in the slide. So the first view which we presented was for checking the summary of the entire, like till date. So let's say if you open an account in the year 2002 and you want your entire transaction summary for that account, it's again a data warehousing concept, but on a higher level, this gets all the records you have till date for only your current account. The next one that we had was for every monthly spending. So there are many financial advising platforms each of the bank offers, but this one specifically tracks across all the products. Let's say you have 3 accounts, one in Chase, one in Bank of America, and one in TD Bank. So this one will keep a track of all your spending analysis and give you your insights on each one, like how much are you spending, how much amount is getting credited in your account, that way. So this one is for debit. Similar we have for credit as well. And that's how we do the analysis in BI.
Okay, it's very clear. Thank you.
Thank you so much. Anyone else?
Yeah, I have another question.
Yes.
So how does the database ensure data consistency and avoid errors during the update?
Yes. So what we had done is, one second, let me go to data. In fact, Yeah. If you want, I can. Sagar, can you take this to the main slide? So meanwhile, I can present it in the bigger screen. Yeah. Yes. Yes. So for each of the entity, so let's take an example. So you have an account for, let's say you have a savings account and you are mapped to a Chase Bank, or let's say Bank of America. You have a savings account in Bank of America. Whenever any insertion occurs, if you check our DDL statements or 1 second. Yes, if you check our yes. Okay, so in our DDL statements, what we had done is each of the tables before populating, we had a check constraint involved over here, which will call a function. On top of that, we have also added triggers. So if you see the 9th slide, which was for triggers. So if you have any, if you transfer the amount, the trigger will update on every insertion. And the same thing occurs for beneficiary as well. And similarly, there are also validation constraint, like function-based constraints, which we created on almost every of the field, considering we are a very sensitive, we are handling very sensitive data. We do not want the data to get corrupted or by, I mean, by accidentally or by no means that way. So, did I answer your question? Or
Yes, thank you very clearly.
yes, yes. Thank you so much. Yes, yes. Thank you, sir. Thank you, everyone.
Great design and presentation from Team 11. Team 11, your reporting and the data analysis were great. Thank you for the great work and thank you for the questions.
Thank you, sir.
Of course. Let's welcome Team 12.
Sure. Can you see my screen?
Yeah, you are on.
Okay. Good morning, everyone. We are Team 12, and today we are excited to share our project with you. My name is Xingyue, and here my teammates Li Bo, Listen, Zihan, and Nan. Our project is Efficient Leave and Carryover Management System. It focuses on creating a streamlined solution to simplify leave applications, approvals, and carryovers, improving HR management efficiency in large companies. Here is the ERD. As you can see, the employee table connects to leave request, which in turn links to leave policy and leave carryover. This ensures every leave request complies with company policies. Similarly, salary info links back to leave request, back to leave records, allowing for automatic adjustments based on leave usage. Now we move to next part.
Thank you, Xingyue. Hello, everyone. Libo. For the design details, our system handle critical functionalities like employee management, leave application, and approval process. We also make sure the referential integrity through well-defined primary and foreign keys. As in this picture, by joining other tables data into the department ID, we can avoid redundancy and ensure accurate data linking. Voucher feeds are also used to accommodate the textual data for more efficient storage and performance. Other standout features include data encryption to secure sensitive information and the use of function-based constraints for enforcing business rules. These design choices enhance both the security and functionality of our system. Moving on to the encryption and constraint, we implemented salary encryption using AES 256 standard. It stores salary data as encrypted binary and also utilizes a symmetry key. This extra layer of protection ensures the compliance within data privacy standards.
For example, without a kid, the decrypted salary here in this picture are not available. As in next picture, we use SQL command to validate leave duration constraint. It failed because it conflicts a 90-day leave limit applied for all general leave via a check constraint. For a quick review of our illustrated design style, let's retrieve the leave request table. This table manages leave application and include a computed column, leave duration dates, self-calculated based on the start and end dates. This is achieved by invoking our validation function within the constraint. We can also put out a form like this. It gives us a clear view of the leave summary for employees, which aggregates statistics like the remaining leave days and cover over days for management. That's all for part 2. Let's welcome my teammate Nathan to go further.
Thank you, Lebo. So today I'll walk you through the core functionalities of our leave management system, which integrates workflow automation, policy validation, and secure salary management into one cohesive solution. So in this, we have the workflow where we have 4 key components. One is the leave request table, which captures and manages the employee leave applications. Then the validation process, which processes automatically policies like the 90-day consecutive leave limit. And then the approval process table ensures transparent decision making, and the salary info table, which handles automatic leave-based salary adjustments with enterprise-grade security. Now, next slide. So here's the key features. Let's highlight 2 critical features. One is the validation functionality, where it enforces rules like the 90-day consecutive leave limit using the function validate consecutive leave limit. Over here, it checks if there are 2 cases. One is the maternity or paternity leave, where we can allow for extended duration. And it also auto-calculates the leave duration using date diff in the leave request table. Now going to the next slide. Over here, we show the check constraint where it ensures the leave policies, which we spoke about earlier, is added, which is excluding the maternity and paternity leave. And most importantly, the salary integration. Here, like my friend Lebo explained earlier, it protects the sensitive salary data using the AES 256 encryption in the salary info table. And it tracks leave deductions and unused leave bonuses with encrypted values. And it also converts unused leave into monetary bonuses based on rules. Now, to conclude, this integration transforms the leave management into a data-driven, secure, and automated process, significantly streamlining the HR operations while ensuring compliance and accuracy. Now, handing over to my friend Zihan.
Hey, hi everyone. My name is Zihan, and I'm responsible for the data analysis and view for our project. Begin with these 3 key important reporting views. The first one is called the leave request detail view. This view tracks the leave request with details. It consolidates data from the leave request, employee, and leave type table. By using this view, we can quickly identify the pending leave requests with a query like this. This highlights the employees, such as Michael and Michelle, whose requests need attention. It enables HR to prioritize the approvals, improving overall efficiency. The second one is called the leave request approval detail view. It is quite similar to the first one, but expanded details such as comments on the approval process, allowing for analysis of approval. The query here reveals that the vacation leave is the most commonly requested. We can uncover trends of the employee's behavior, which guides policy optimization to better align with the employee needs. The last one is called the employee leave status view. This view summarizes each employee's leave usage, integrating data from the employee and the leave statistic table. The result shows that the operation and the compliance have highest leave usage, indicating a potential workload imbalance. The management can address this by redistributing the resources and providing additional support. So in summary, this view and analysis demonstrate the flexibility and functionality of our database system. Our database system provides an actionable insight and empowers smarter decision and more efficient resource management. I'm done with my part. Let me hand it over to my friend now.
I'm present on our leave management system visualization analysis. The department leave overview shows that operations has the highest usage, primarily due to maternity leave. The leave type distribution pie chart reveals vacation as largest share, followed by sick leave and personal leave. The department leave matrix heat map displays leave intensity across departments, with dark colors indicating more days taken. More importantly, this chart works interactively. When specific data is selected, all charts update simultaneously. For our carryover analysis, this chart combines carryover count in blue bars and average remaining days in the purple line. We can observe that the departments like innovation, lab, and product management show higher carryover counts. The average remaining days vary significantly across departments. To conclude, we have three key achievements: secure data encryption, automated calculations, and efficient approvals. These features have streamlined HR operations. Future enhancement will include mobile support and advanced analysis capabilities. Thank you. We are happy to take any questions.
Hello.
Yeah,
I have a question. Hello.
Yeah, go ahead.
Yeah, so one of the views that you implemented, I saw that there are many entries where the leave request is shown as pending. So do you have any triggers or any check constraints like that it will auto approve after a certain number of days? Or what if nobody approves that leaves? What will happen?
I didn't see babies.
Yeah, I'll repeat my question. So what I'm saying is, can you go to the view page, view presentation slide? The views that you have implemented, the back.
Here?
No, go back. Back.
Oh.
Yes, that one. Yeah. So I see there are many approval status as shown as pending. So is there any triggers or check constraint that you guys have implemented that auto approves after a certain number of days has passed, or what if nobody approves any leave of the person? So how do you counter that?
Yeah, so this there's a trigger set to like deal with this circumstance. So there's a trigger. So whenever an unapproved request was like due for 3 days, the trigger will like mark it as to notify the relevant personnel. So it will automatically check if the leaves request remain unapproved after like 3 days, and logs a notification in the leave notification table.
Okay, but I do see that there is one of the last entries like John Smith. It's more than I think 29 days. So you said it's 3 days. So how do you counter that?
So currently, we haven't implemented for the validation process. It has to be done from the authority, whichever the reporting manager should be. So as of now, there are only conditions and check levels as to what kind of leave can be taken, and the enforcements are on three things. One was it shouldn't cross the 90-day limit, and only if it is maternal or paternal leave, only then it can be approved. So there are few cases like these which we have implemented already. Yet we can, for future enhancements, if it is pending over certain time, we'll have to probably add in a check over there to automatically either approve it or reject it.
Yeah, that addresses. Thanks.
Yeah. That. Any other doubt?
No, that's it. Thanks.
Thank you. Yeah.
Great work
thank you.
and presentation from Team 12. Your workflow and the data analysis were wonderful, and the question was great and interesting. Thank you.
Thank you, Professor.
Thank you.
Thank you.
Sure. Let's welcome Team 13.
Yeah. Good afternoon, everyone. This is Apurva. We are group 13. Our topic is grocery database design project presentation. And my teammate includes Yaho and Zippy. So the background of our project is that our database aims to centralize and streamline business data management. Goal was to support operational data tracking and enable real-time and historical reporting and enhance decision making through reliable insights. And then ERD, our key design choices were the ERD, which defines relationship between entities like customer, transaction, and inventory, which I will give more details in the coming slides. And tables are logically grouped based on the business requirement. And we made a table structure so that schema is normalized to eliminate redundancy, and foreign keys enforces referential integrity. And we had few constants and rules. Constants, there were like 3 constants: primary keys, which ensures unique identification of entities; foreign key, which establish and maintain relationship between tables; and unique constant, which enforces uniqueness for critical attributes. And the rules were computed columns, which automated calculation of derived rules; triggers, which ensures consistency across related tables; and views, which provided simplified access to aggregated data. So now in database design and highlights, there are key points. First was computed columns, which simplify complex calculation and automated the derived data generation. And then we had modular schema design, which ensured scalability and maintainability by organizing the schema into logical reusable modules. And then we had views, which provided tailored insight specific design for reporting and analytics. And then robust constraints, which maintain data integrity and consistency across the database. And now our ERD. So we have entities as customer, which stores customer details such as name, contact information, and feedback. And the relationship is linked to transaction via customer ID to track purchase history, and it's connected to feedback for capturing reviews and dating and ratings. And then we have transactions, which tracks purchase information, including transaction date, amount, and payment method. And the relationships is linked to transaction details to specify product purchase, quantities, and unit prices. It is also connected to payment for recording payments details such as method and amount. And then we have product table, which maintains product details such as category, price, and inventory status, and its relationship is connected to category via category ID for classification, and it is linked to inventory to track stock levels and availability, and it is also associated with supplier through supplier ID for procurement tracking. And then we have the other table, supplier, which stores supplier information, including contact details and contracts, and it is linked to product to indicate sourcing details, and it is connected to supplier contracts to formalize agreement. And then we have inventory, which tracks stock details for each product, including available quantities and reorder threshold, and it is connected to warehouse to associate stock with specific storage location, linked to product for stock status updates. And then we have feedback, which captures customer rating and comments, and it is linked to customer via feedback ID to associate feedback with specific customers. And then we have the payment table, which records payment information, including method, date, and amount, and it is linked to transaction via payment ID to associate payments with purchase. And then we have category, which classifies product into distinct category for easier management, and it is linked to product via category ID. Now my teammate will go with the further slides.
Okay, let's go through the database implementation. So according to the ERD, we just designed the necessary foreign keys and primary key to relate all the tables. And also we just define all the data types. And let's go through the completed columns. So as you can see right here, we have a needs restock column here, which means like this shows whether we need restock for a specific inventory. So if whenever the quantity is below the restock threshold, right here you gotta show yes. Otherwise you gotta show no. And right here we have 2 more computed columns here: full name and monthly salary. And right here we have the profit. This is also a computed column, which equals price minus cost. Let's go through the constraints. So all of the constraints below are quite like trivial and easy to understand, except one, which is status is valid. So basically we have three status. The first one is pending, second one is canceled, the third one is completed. So whenever you try to insert an data whose data type is not among those three types, you gotta show an arrow. So if you violate any of the constraint here, we are gonna show arrow here. So the data insertion will fail. And right here, let's go through the views. So we have a lot of views here, but due to the time limit, we just pick some interesting ones to explain. So we have payment views, which is the views of the number of different payment methods. Here, for example, if we notice there's a lot of PayPal payment at one of our location, so which means we may just need to add more devices like NFC devices there to give our customer better shopping experience. So we also have status view, which shows the number of canceled, pending, and completed orders. And this is super important for us to run a grocery store. For example, we definitely need to know what is the inventory that is already expired or is almost expired. So if it's expired, we just need to know where it is, and we have to get it out from our warehouse. If it's almost expired, we definitely need to do more promotion on it and try to sell it as soon as we can. So right here, we can see the location of the nearest expiring inventory here and the expiration date. And also with time, there's a customer that complete order. They can rate our order. So by their rating score, we can know whether they like our product, whether they like our service. So we can do some improvements according to the rating score. And also we have capacity here. So we can know how much remaining capacity we have in at our different warehouse. So we can just know how to better allocate our resources and new inventory to different locations. So I'll hand next part visualization to my teammate. You can start, Sepei.
Sorry to interrupt, time is up.
Can we have like 1 more minute?
Yeah, go ahead, please.
Okay, thank you. You can go ahead, Sepei. Okay, I don't think she's here. I don't know, maybe there's some technical issue, but I'll explain the rest. So right here we can see the total amount of transaction of different kind of products here. So we can know who is the best seller, then we can maybe like have more inventory of it. So right here is our warehouse visualization. So we can know the distribution of different kinds of goods, what's their capacity, and how many inventory you have. Right here we have some employee visualization, so we can know the gender of a different gender, what's the percentage of different genders, and we also could know their salaries and their department, and also their total salaries. That's it. Thank you. Free to ask any question.
Hi, can I ask a question?
Yeah, sure. Go ahead.
For the inventory table, I noticed there's a needs restock field as a computed column. How exactly is this calculated?
Wait, let me get to there. Okay, you mean this? Hello?
Yes, correct.
Okay, so what's your question again?
Is that a computed column? Needs
Yeah,
to be
it is.
the-
The logic is if a quantity is below or lower than the restock threshold here, you gotta say yes. No, yes here, but obviously right here the quantity is all above the restock threshold, so it's all no here.
Okay.
Thank you for your question. Any more question?
Great work and presentation from Team 13. And don't worry about the technical difficulty. So your performance will not be impacted by that. And thank you for the question. Yeah.
Yeah.
Let's welcome Team 14.
Hello, everyone. So this is Rudrang, and we are part of Team 14. Our topic for today is real estate management system. Let me give you a quick introduction to my teammates. They are Harshal, Mansi, Nikhil, Sachi, and Saiti. So before we move ahead, let me tell you why we chose this project. So real estate, you may be a tenant, you may be a agent, you may be a owner. It's a big hassle because everything is distributed. So the aim that we are doing is to challenge a thing and provide a structure where everything is available under one roof. So next slide. Here's a list of context that we'll be covering. My teammates will take on their respective task and we'll move ahead. So let me go to the overview. Next slide. Yeah. So the main objective was to develop a secure platform that simplifies the property management for owners, agents, and tenants. So our mission aim was to ensure data accuracy, to provide a streamlined process, deliver insightful reports for better decision making, and to have encryption to protect the personal information. So key features includes reports like expiration leases, property insurances, what is the average income, and other stuff. Then there is encrypted personal information like phone numbers, email. Moving on to the next slide. Yeah. So as I said, the purpose is to simplify it all for the owners, for the agents, and the tenants. So the business problems that we have addressed is accurate record management. So we are maintaining up-to-date records. Then we are we are creating, keeping track of the maintenance request, payments, inspection cost, lease expiration to provide an improved oversights. Then we have done data-driven decision making so that we get detailed views for lease agreements so that they'll be able to plan their finances, lease expiration so that no critical deadlines are missed. Then there is data security. Using encryption, we are maintaining data security. Now, Saiti will take on the ERD.
We have total 16 entities, property being the central entity. It links other key tables. Next is the owner, tenant, and lease agreement. The owner has one-to-many relationship with properties as one owner can own multiple properties. Tenant entity with tenant details is connected to lease agreement, and lease agreement acts as a bridge between property and tenant. Next, we have maintenance request, utility billing, payment, and amenities. All these entities are connected to property for easy retrieval. And next, we have property type, property features, property valuation, and property insurance. All these are also connected to property for financial analysis, classification, to enhance descriptive capabilities and safeguarding against risk. Lastly, we have address, agent, document, and inspection entities. These have information related to geographical area, maintenance, and easy document retrieval. Over to Harshal.
Hello everyone. I'll present the core tables in our database, starting with the address. Next slide, please. Which records the location of properties, and the owner table, which stores encrypted personal details of property owners for the security purpose. Next slide. And then property type and property table to categorize the properties. Next slide. The tenant table to keep the track of the individuals leasing these properties. Moving to lease agreements, this table manages the uh, contractual details of leasing, including durations and payment terms. Then property insurance to ensure properties are covered, and payment table to record the financial transaction for lease. Then agent table to link the agents managing these properties, and maintenance requests to help track for property upkeep. Next slide. Utility billing. This logs the expenses and which are related to the utilities, and property features and amenities table to detail the attributes that enhance property value, and property valuation to keep the records of assessed property values. Next slide. And lastly, document to track the critical paperwork, and inspection to ensure compliance and regular property checks. And together, these interconnected tables ensure comprehensive management and efficient data tracking for real estate operations. Now I'll ask Nikhil to explain the table level checks.
So I'll be going over the table level checks. So the script here is designed to manage property data with robust integrity constraints. The property ID is an auto-incrementing integer column defined by the identity property, ensuring like each property has an unique identifier. This table also establishes relationship between three foreign keys: address ID, property type ID, owner ID, enforcing referential integrity. Key attributes include the rent amount, which is set as decimal to handle precise monetary values. Property size is int to represent the property dimensions in square feet. Two constraints ensure data validity, that is the rent amount and the property size, and is set between like a realistic range between 100 and 10,000. So these elements ensure property table maintains accurate, consistent, and meaningful data within the database. Next. So the lease agreement table is designed to manage lease data and to ensure data entry be implemented constraints. The lease date enforces the lease that is end date is after the start date. This lease rent ensures the monthly rent is positive, and lease deposit guarantees the security deposit is non-negative. The monthly rent and security deposits columns use the decimal type of precise financial data, while term stores the detailed lease terms as free text in varchar. Next.
My name is Sachi. I'll speak for encryption. We have used multi-level encryption and column level encryption. We implemented encryption using AES 256 algorithm with var binary storage, since it's both secure and efficient. Encrypting all the columns seemed unnecessary, so by encrypting only specific columns in the entire table, or encrypting the whole database, we can maintain good performance and run fast queries on unencrypted columns while keeping sensitive data secure. This design lets us control who can see the encrypted data as well, and we can grant access to basic information while requiring special permissions to view contact details. Next, Mansi will explain about views.
Yeah, so let's dive into some of the key database views that we have developed for our project.
Our first view, property insurance details, brings together crucial insurance information for each property. It showcases the insurance provider, policy details, and calculated coverage duration in the days. By integrating this data with complete property addresses, stakeholders can easily track policies and identify potential gaps. Now, moving on to the tenant payment history view. All tenant payment information is centralized in one place. It displays payment dates, amounts, methods, and links the tenants to their respective properties. This comprehensive view allows property managers to efficiently monitor financial transactions and addresses the overdue payments with ease. Moving on to the next slide. The upcoming lease expiration view is designed to ensure proactive lease management. It identifies lease expiring within the next 90 days, listing tenant names, property addresses, lease end dates, and remaining days until expiration. This enables property managers to stay ahead with renewals or marketing efforts for vacant properties. And lastly, the maintenance operations are streamlined through our pending maintenance request view. It provides details about unresolved requests, including descriptions, tenant information, property locations, and assigned agents. By focusing only on pending issues, this view helps prioritize tasks, ensuring quick resolution and higher tenant satisfaction. So next, Harshal will explain about the functions.
The first, security deposit status. It calculates whether a tenant's security deposit is fully paid by comparing total payments made against the required amount. It returns a clear status of paid or pending, ensuring accurate tracking of deposits for each lease. Next slide. The second function, payment status, it identifies whether a payment is on time or late by comparing the date of the payment against the end date of the lease. And these functions enable ease of operations, and it offers insight into the financial transactions.
So we'll be visualizing a few aspects of our database. So here we can see that the property list is listed, and the agents that are listed as their work to do is also there. So here you can see there are two properties for which one agent is listed. So what we have made sure here is the agents that are assigned here uh, go through various property addresses, like the key constraints in the property address. So they make sure that agents are not assigned to places that are demographically like difficult to handle. Next. This visualization using the property and the address table from the database gives us a this tells us how the properties are spread over the country. If you can closely see the properties, data that we populated here is majorly towards the California state, which will be referred to the next visualization. So if you see, there were majorly more properties listed in the California area, and which is where the highest rent is being collected, which by which we can correlate the higher rent incomes to the demographic. So next.
In conclusion, we have addressed critical challenges in property management by providing a secure, efficient, and user-friendly platform. Moving forward, we aim to expand our functionality by integrating APIs for property valuation and analytical dashboards while improving automation and real-time updates. Thank you. Any questions?
Oh, yes. I noticed there's a table called feature, right? So there's an attribute called feature description. So can you give me example of it? Like what's a feature description?
Yeah, so to quickly answer, quickly give you an answer to that question, that your properties will have a lot of features, like for example, a unit or an apartment has a modular kitchen installed in it, so it constitutes to that.
Okay, thank you. Thank you for your answer.
Hi, can you hear me?
Any more questions?
Hi.
Yeah.
Oh, sorry, because I have some, I'm team member from Team 30. I have some technical issues just now. And my question is, do you have a process for database maintenance tasks like re-indexing, removing your outdated data, or updating statics to ensure optimal performance?
Yeah, so we have a trigger that has been used. So it actually uses the agent. So if the agent assigns a property as currently off market, it will, in the next population, it would remove it. So the tenants will not be able to see the property.
Okay, thank you.
Great design and presentation from Team 14. Your reports and the visualizations were great. Thank you for the great work, Team 14. And the questions were great and interesting. Thank you.
Thank you, Professor.
Of course. Last but not the least, let's welcome Team 15.
Thank you, Professor. So I'm going to be talking about our database design that we have implemented for an online electronic store, and we're calling it Electro Hub. So our database design mainly focuses on providing a comprehensive database system for like an online electronic store. We have designed a database in such a way that it enhances operational efficiency and customer experience through effective data management. It is also a reliable. It also has a reliable infrastructure, and we've made sure that it can be scalable for any future e-commerce operations that can be implemented for the store. So let me just give a brief overview of the database design. So we have several tables like for inventory, sales, and customer interactions, so that we can manage data across those e-commerce operations. And we support order processing, personalized customer experience, and we can use the data for analyzing our business needs and business operations. And we have these intermediate entities between two tables that can handle many relationships more effectively. Now my teammate is going to continue on the entity relationship diagram.
So Vivek.
Sorry, I was speaking on mute. Yeah, the core entities of our database are product, customer, and order. Product it has a many-to-one relationship with category and brand, and it has a one-to-one relationship with inventory, and it also it's also related to the promotion entity. It has a many-to-many relationship with the promotion entity. So we have added a intermediate table called promotion product to resolve the many-to-many relationship to one-to-many. And some of the key design decisions we took were for wishlist item ID. We don't have a separate primary key. We are using wishlist ID and product ID. We are having a composite key. And for inventory, we don't have a separate primary key. We are using the product ID of the product. And right now, the customer can only have one wish list, but we are using a wish list ID to to handle the scalability issue. Okay, if we want to enable customers to have multiple wish lists in the future. Yeah, that's about it. Next, Satvik will present the database implementation.
Yeah, based on the ERD and the databases, and these are the table creation scripts that we have for all the different tables in our database. And so, and here are the sample data that we have populated in these tables in our database for brand categories, products, and for customers and different promotions. So, and these are the table level constraints, check constraints that we have implemented. For promotion table, we have a validate promotion constraint, which checks that the promotion start date is less than the end date and discount is greater than 0, and it does not increase more than 50. And we have another validate positive amount table level check constraint for the order table to make sure that the total amount is always positive. And next, we have database trigger. So we have this trigger set up, the update total amount trigger. It automatically updates the total amount column in the order table whenever like an insert or update operation is done on the order item table. It ensures that the order table reflects accurate totals because total amount table is populated from the multiplying quantity and price from the order item table. And this logic always make sure it has the accurate value for total amount as whenever there's an update to the order item table, it checks, it deletes, like it subtracts the previous value of the previous value and then adds the new value so that accurate data is present on total amount table total amount column. And the key advantages of doing this is it automates the maintenance of total amount, reducing the need for manual updates, and it improves data integrity and prevents any discrepancies between the order and the order item table. Next, database views will be explained by Sanjay. Thank you.
Okay, let's start with the customer product hierarchy. This view provides insights into customer product interactions by focusing on product with high customer ratings and products from specific categories like smart devices, TV, and home theater. And this also solves business problem by highlighting highly rated products, and business can prioritize managing these products effectively within specific categories. And the output columns consists of customer name, product ID, product name, product price, category name, and brand name. Yeah. And next, yeah. Next, priority order insights. This view identifies and prioritizes high value orders, partially paid orders, and orders with multiple products. This also solves the business problem by simplifying the process of identifying high priority orders based on value, payment status, and order complexity. And next, inventory management view. This view provides a comprehensive overview of inventory levels, sales trends for stock status like critical, low, moderate, and high. The business problems it solves is by highlighting stock levels and demand, allowing proactive restocking and efficient uh, inventory allocation. And the output column consists of product ID, product name, product price, category name, brand name, stock quantity, and stock status. Uh, Thank you.
Yeah. One second. Yeah. So the first report focuses on the sales metrics of a database. So the purpose of this report is to analyze the revenue trends, top selling products, and categories by the category name. As you can see, the total sales revenue was around 38.49K, and you can also see the sum of total quantity sold by name and also the sum of total quantity sold by the category names like audio, gaming, laptop, computers, and etc. And for these metrics, I basically use the DAX measures and columns. And so the primary objective of this is to find the total revenue across dimensions like category, brand, etc., and also like identify the sales with expect like daily or weekly or basically in the future we can also like uh, analyze the monthly sales trends as well. And the next report focuses on the products insights. So this particular report basically categorizes the stock quantity, and there was and also focuses on the average rating of the top
I'm sorry
top
to
five
interrupt.
products. And also there was a promotion campaign which was run by our product, and as you can see the sales outside the promotion was more, and as you can see the sales increased during the summer sales, and the back to school sale was also increased. And this particular report also focuses on outside promotion with respect to the dates or yearly by the quarter. And in this report I focused on the order date to with respect to the month November. And basically, in conclusion, this analysis tackles key business challenges, by enabling efficient product management, and we can also optimize the inventory, and also we can drive some campaigns which are personalized to the customer experiences. Yeah, thank you, and we are happy to address any questions.
Yeah, I saw that you have a promotion entity that is linked to the product. So, like, how are you determining which products to be promoted for the discount?
Yeah, right now there's no mechanism to determine if a product is eligible for promotion. I mean, I think we randomly decide if it's going to be.
Oh, sure. One more question, and how are you keeping track of the inventory as well?
Yeah, it's with the help of the product ID, and we have a column called stock quantity.
And is
And
there like a shelf life for all these, or like non-perishable?
right now we haven't implemented any shelf life or
Okay.
stock added date, but these are all electronics, right? I don't think a shelf life is required.
Yeah, makes sense. Thank you.
Great work and presentation from Team 15. Your reporting was wonderful. Thank you, and thank you for the questions. This is the end of our project presentation for DAMG 6210 for 2024 online. I was impressed with your accomplishments in this class. You all had great presentation skills. Kudos to everyone.
Thank you, Professor.